All right. So an odd one, if you're someone that likes to do it their own way and reason through it their own way and then not show their work, this is the question for you. Sure. Numbers coming out of thin air. Now, anyway. Okay. Best thing that I want you to do if you look at a question like this, we'll walk through it. It's financial compensation for amount of home runs that professional baseball players are hitting. So each player's salary for a season is made up of a base amount plus a performance bonus. Stop talking. Not right now. If I'm recording and I'm up here, you're not there. Okay? So the bonus is calculated according to the number of home runs the player hits during the season. So there's basically a payment structure, and it goes up when he hits a new level. So it's not like every home run he hits, he gets more money. It's every X amount. So looking at this here right now, and this is like the biggest part of it, and I'm just going to give you a little bit of a hint and write out something like that. Okay. Can anyone tell me right now two things? When does this cost structure kick in? And it's kind of hidden in there. After how many home runs do I step up to the next level? You can kind of figure that out just looking at the rule that was provided. So where does this thing kick in? And after how many home runs after that am I actually making more money? Okay. You can understand this part of it, then this guy becomes really easy. Otherwise, there's like some complex math we have to do. I'll show you both ways. Just going to pause this for a sec. All right, I'm going to slow it down a little for our...
dumb it down.
Dumb it down? All right, for our chimps in the back. What? Better than me walking around. Sorry. What? Like the rest of the year? Okay. All right. I'm doing curling tomorrow, so we'll walk down like that. Yeah. Okay. So.
What happened to library with Susie?
It was Mr. Gruber. Okay, we're recording. Okay. A, we don't know. B, we know is actually 0.2. Okay. What about that is helpful to me? What do we know about B and its relationship with step length? Can you figure out and tell me what the step length might be in this case? Yeah. 5. 0.2, you should be getting pretty decent at, like, if you see like a 0.1, what would the step length be? If I saw like a 0.2, hoping that you guys know, and if you're not sure, right? A couple of ways you can do it. You can just try a bunch of fractions until you see one that actually fits it. But there's a reason why they put that as a decimal, not 1/5. You'll see a bunch of other questions. They're always going to have like it as a fraction. They did that to make this a little bit tougher. But I want you to know that you can figure this guy out relatively easy. So that means what? And I'll add one layer of context to it as well. X is number of home runs hit during the season. Y is the player's salary in millions of dollars. So if I know that there's a relationship between the x-axis, which is home runs hit, the B value, does it relate to the y-axis and the player's salary? Or does it relate to maybe the home runs being hit? The home runs being hit. So then I'll ask it again. After how many home runs is a guy going up to the next pay structure? Just every 5. Because the length here, right? Or crap, I did it. The actual fraction here, kind of explain that backwards. The actual fraction of this guy, you're right to say that, be 1/5. So the actual length would be equal to 5 because it's just the reciprocal of that, right? The fraction, B as a fraction is 1/5. So the reciprocal is going to be the length. Apologies for that. That step length is indicating, right? If we think about these guys here, the way that this is going to work, every time I get 5 home runs more, I'm going to go up to the next sort of millions of dollars kind of bracket. Now, that's what makes this guy challenging. This is the rare grade 10 question where you are missing on this rule both A and you are missing K right now. So let's dive in a little bit deeper and think about what the heck does H mean with regards to this? Does it deal with the x-axis? Does it deal with the y-axis? What's this telling me right now? What is that x minus 20 informing me? What is H? 20. Okay. So then when does this whole thing start to kick in right now? When does the payment structure start to kick in based on this guy? Starts at 20 home runs. So at 20 home runs, I reach the first level. Okay? So armed with this information, knowing that for every 5 home runs extra beyond 20, I'm going to go up to another step. But as soon as I hit 20, I'm actually going to be getting a nice little bonus in there. I want you to read that first bullet point, okay, and try and decode this on your own. I'm going to pause this guy and give you a little bit more time to think about this than normal, and identify what that is actually, what can I actually derive from that Carl hitting 23 home runs? What did we find out then? What do we know from Carl hitting 23 home runs, knowing that this payment structure kicks in at 20 home runs, and then for every 5 home runs after that, he kicks up to the next structure? What can I derive from Carl hitting 23 home runs and a salary of 23? What can you figure out from that? If you can't see it logically, let's do it mathematically, and then we'll come back to it. So when I say mathematically, right now, if we were to kind of look at a scenario where I've got 2 points, okay, let's actually plug one of those points in and see what we get out of it. As in, y is equal to an unknown a, 0.2, regular brackets, x minus 20 plus k. So 9 million, you can leave it like that. You don't have to write out the extra. 0.2, 23 minus 20 plus k. So internally, we just keep working inside this bracket. 0.3 times 2. The a is still unknown. This guy's a 9. Right? 9 is now equal to a, funky brackets, 0.6 plus k. When I execute these brackets, what's my objective? Round down. So if I round 0.6 down, what does it become? 9 becomes 0. What is 0 times anything? 0. So 9 is equal to k. Mathematically, we were actually able to solve for it because that first step, that first point canceled it out. Now, this wouldn't work if we plugged in the next point. Why? Let me think about that for a second. What? He's leveled up. He's already leveled up. So he's at a different spot. Here's what I wanted you to logic and reason your way through here, okay? Was this guy right here. We didn't know what the K was, but we knew right here at the beginning of this, H was 20, K was unknown. We knew that the step length was 5 units over. So when I look at Carl hitting 23 home runs and making 9 million, what step was he on? He was right here, right? Carl hit right there. He hit 23. So if Carl made 9 million for hitting 23, then he's on the first step, meaning that 9 million just becomes the K value, right? That's where these guys are like the most challenging, is that there's like logic puzzles built in. So if they make the greatest integer function, because there's different levels of questions, this previous one here, I mean, even Brooklyn was able to like hack it and find an easy way to do it. But that one's a lot easier to kind of work through.
What do you mean by that?
I meant that as a dig. It worked. Yeah.
So 9 million is just like the base,
Yeah.
basic level payment.
Yeah. So that's the logic. Connor, focus, buddy. That's the weird math logic that has to happen here, because there is another skill set that can be used in this case, but it's more of a grade 11 skill when we've got 2 points and then this guy here. It would still work. It's a much longer process, but it's more of a grade 9 or grade 11 SN skill that we technically don't need here. This one was trying to get you to reason your way through it or plug one of these guys in and just see what happens. See if I can get anything out of it. So kind of a challenging one, because if you can't figure out what that K is, then you can't get what the A is, meaning you really can't go anywhere with this question. All right, now that I have that as a value, as a known value, can we go ahead and figure out how you would figure out what the A value would be in this case? How am I going to figure out what the A value is? Again, I'm going to show you right now. You can either calculate it, so calculate it, or we can reason it. Okay? I'll have you think about this for a second, then I'll pause it. If Carl is at the base salary, right, 23 home runs makes $9 million. It goes up a certain amount, per million every 5 home runs. So if Carl hit 23 and is making $9 million, and David hit 32 home runs and makes $9.6 million, I want you to think about how we could reason what the value of A would be based on that. And I'll just pause this and let you think. I prefer the sketch. It makes sense to me. But I want to reason through this. So we'll start again here and just draw it out, right? This was 20 and 9, right, gents? And then I know it kicks up every 5 home runs. So that means this is 25 and something I'm not so sure of, okay? But I do know that this guy right here is going to be 30, and again, something I'm not so sure of. That 32 home runs that Carl hits is right in here, right? This is a 5 home run section. He hits 32, or he hits 32 right here. And I know that David made 9.6 million. So that step for anyone from 30 to 35 is making 9.6. Can you now fill in the missing blank and reason what this guy would be? He would be 9.3. Meaning your A value, just from logic alone, and sketched out so I know what you're thinking, and sketched out so I know what she's not focusing. Okay. See how you can kind of follow what's going on? It's not just numbers coming out of the. Yeah. All right. I'll stop. Yeah, it did.
You just had to look for 1 second.
Yeah, that was a lot. That's a lot for me. The other way around it, right, is for you to go ahead and calculate it. So if you're not big on this mental reasoning stuff, well, then let's go ahead and calculate it. We can use whatever point we want, to be honest with you. Let's try using that 32 and 9.6. So 9.6 is equal to an unknown A, 0.2. He hit 32 home runs. There was the H value, plus 9. So I've solved for the 9. I'm using this point here, and then I'm just going to go and solve for it. You can use any point if you want to figure out the rest of the rule. Either of them would have worked. Bring this guy over here, right? 0.6 is equal to A, 0.2 times 12, right? So we're now going to execute what's in these brackets here. So what is that going to leave me with? What's 0.2 times 12? Make sure. So I've got 0.6 is equal to A, and then 2.4. 2.4. Again, once I have numbers inside these funky brackets, I'm going to end up with 0.6 is equal to A, and then 2.4 just becomes 2. Now I can just divide by 2. A is equal to 0.3. Okay? So we can either calculate these guys or we can reason our way through these guys. But I think that's what also makes it kind of challenging. What I will suggest to you if you're writing this on an exam is just plugging numbers in and seeing if you can get anything from them, right, before you go anywhere else. If you plugged in the 32 and the 9.6 originally, it still would have been broken because you would have an A and a K. It just so happened that this guy ended up working out. They're almost like forcing you to try and reason this guy, which is kind of mean in a way. So now at the end of that, I actually have a rule, right? So the rule of all of this is now y is equal to 0.3, 0.2, x minus 20 plus 9. Now, your objective was to figure out what Michael's, we're trying to figure out how many home runs Michael would have hit if his salary was 10.5. Okay? And they are very specific in the language. At most, how many home runs could Michael have hit last season? So the last part about this is getting you to figure out a value of X. There's going to give you a range. It's going to give you a low end and a high end. And you're going to have to figure out at most how many could he have hit based on the answer that we find. So I'll just walk through this one relatively quick, knowing that 10.5 is a final value. 0.3, we're working into that. We're going to work our way in towards this block right here. Okay? Meaning, let's get this guy out of the way. We want to get rid of A and K in this case. So he gets brought over. I now have 1.5 is equal to 0.3. And again, just to reiterate, I'm trying to isolate for BXH. You don't know this now, but this is actually going to be quite helpful when you come to sine functions next year. The kids are doing right now in the other grade. 0.3. Now, it is imperative that at this stage we have an integer on the other side. Doesn't matter if it's negative, but I need that guy, that 5, to be an integer and not a decimal. Otherwise, it's broken. I've done something wrong. Here's where things split off, right? We're going to have the two answers. So I'm going to draw these guys, one here and then just one here. So I'm always going to put what's inside the brackets. This is me getting rid of the brackets, by the way. Is equal to 5 or greater than and equal to 5. Let's do that right. And then this guy here is 0.2 x minus 20 less than 5 plus 1. So now it's just a matter of like solving this stuff. Divide by 0.2, divide by 0.2. X minus 20 is greater than and equal to 25, right? And then this is 0.2 x minus 20 less than 6, dividing x minus 20 is less than 30. Okay? So in that range, okay, so 5, we bring this guy over here. X is greater than and equal to 45. X is less than 50. So we've got, if you got to here, I'm giving you like 9 out of 10, right? If you can get down to there. And that's a huge one to get there. But if you want to get 10 out of 10, looking at the way this is written out now, at most, how many could he have hit? Does everyone see why it's 49? Right? Because this guy is X is less than 50, right? As soon as, if David or whatever his name is, if he had hit 50, he'd be making like $10.8 million, right? But because this has greater than and equal to 45, like if they said what is the least amount of home runs he could have hit? You would say 45. You would take that number exactly. But because they said at most, and because this is less than 50, not less than and equal to, then we would say at the final part here, 49 home runs. Okay. And that's this guy in a nutshell.